Hi, my name is Stephen Kai Tran, and I am in the Radiologic Science program at California Baptist University. Today, I will be doing a presentation on Introduction to Radiation Protection and Safety. The objective of this is that students will be able to recognize the basic concepts of ionizing radiation, such as radiation types and how they interact with matter. Students will understand about radiation dose measurements and units, including absorbed dose, equivalent dose, and effective dose. Students will be able to learn and apply safety practices and procedures to minimize radiation exposure, such as ALARA, time, distance, and shielding. Why is it important to understand radiation protection? When it comes to the word radiation, many people only see it as a negative thing. But there are pros and cons of ionizing radiation. The pros is that it helps with medical imaging, and the cons is that there's different things that could happen when you are exposed to radiation. And this is also to keep patients and occupations safe from unnecessary exposure to radiation. And in order for us to explain radiation to patients and help them with the exams, we as a technologist needs to know and understand the importance of radiation in general. What are the types of ionizing radiation? We're only gonna go over a couple of these. Um, the first one that we're gonna go over is alpha particles. Alpha particle consists of two protons and two neutrons. It has high linear energy transfer, and the common sources that it comes from would be radioactive elements like radium, uranium, and plutonium. The second one is gamma rays. Gamma rays are electromagnetic radiation similar to X rays but more energetic. This has high penetrating power and can travel significantly through materials, and it originates from nuclear reactions. The next one we're going to talk about is X rays. X rays are electromagnetic radiation. It has similar properties to gamma rays but are produced at lower energy. This is widely used in medical imaging, industrial inspections, and scientific research. Coherent or classical scatter. The X-ray photon is initially absorbed by the whole atom, then the energy of photon is injected out of the atom as a photon with the same energy in a different location. This has no ionization that occurs, and it also has no effect on patient dose. Although this has small effect on image quality, but it is least likely of all interaction because it occurs at low photon energy, less than 100 kilo electron volts. The next we have is Compton scatter. The first step of this is X-ray photon is partially absorbed in the atom by an outer shell electron. And then the ionization occurs and electron is knocked out of its orbit called Compton scatter. The remaining photon and energy is carried away as a scattered photon. This is not good because it increases dose for the patient, and it is not good for image quality because it lowers the contrast. The next one that we're going to talk about is photoelectric absorption. Photon is completely absorbed by an inner shell electron, and then the ionization occurs when an electron is removed, making the atom unstable. This is when the ejected electron is called a photoelectron. And the last step of this is that because the atom is now unstable, the cascade effect occurs, creating a characteristic photons. This is not good for a patient because it also increases their dose. However, it is good for image quality because of differential attenuation or absorption is what creates contrast in the image. The low absorption creates the low absorption creates dark areas and high absorption create bright areas. The next one is absorbed dose. Absorbed dose is energy absorbed per unit mass, which is joules per kilogram. The joules is energy and kilograms is mass. The results of photoelectric and Compton effects in the tissue. This is used to measure short-term effects Absorbed dose equals joules over kilogram, and this is expressed in gray. Next one is equivalent dose. This is used to compare biological damage from different types of radiation. This takes into account the radiation type exposed to and the LET, which is the rate at which energy is deposited. This uses a radiation rating factor, which is equivalent dose equals absorbed dose times radiation weighting factor. This is expressed in sieverts. The effective dose compares biological harm based on radiation type and type exposed. This used to measure short-term effects, and this also takes into account of tissue radiosensitivity. This uses both radiation weighting factor and tissue weighting factor. The equation for this is effective dose equals absorbed dose times radiation weighting factor and tissue weighting factor. This is also expressed in sieverts. The cardinal rules is ALARA, as low as reasonably achievable. The primary goal is to minimize radiation exposure to individuals and the environment while still achieving the intended purpose of the radiation source. The radiation protection, which is time, minimizing time of exposure, distance, maximize your distance from the source and patient, shielding, shield yourself and the patient when needed. The class activity that we are going to do is testing out the shield. The objective is to understand the principles of radiation shielding and its effectiveness in radiation protection. The materials needed is a variety of materials to act as a shield. For example, we're going to use sheet of paper, aluminum foil, and plastic wrap. And then a light source, flashlight or light from a phone. And then a radiation detector simulation. This can be a smartphone with a light meter app and a dark room. The procedure is, first we're going to divide the class into groups of 4. And then we're going to have one student from each group shine a flashlight, have another student from each group hold the light meter or the phone, and then another student will hold the material in between the light and the phone, and then one student will measure the light intensity. So the students will take turns doing each of the things so that everybody knows what to do, and then they will discuss about their observation, the effectiveness of each material in blocking the light, which material block out the light the least, and which material block out the light the most. And this is my reference.